So here, the question says, given that given the graph in the adjacent figure, it represents part of the graph of the function. Now, which function are we talking about? So if you look at this one, we have two possibilities. What are the possibilities? Now observe that maybe the graph can be a graph of sine here, and I can mark it up like this one. So if this is the case, that means we are going to have cosecant. So in that case, we should be having an equation of the form y equal to a cosecant of kx plus, let's call the constant, say b, for instance. Now this is a possibility for cosecant. Also, it is possible that this is going to be secant. For instance, if the graph should start from here and end somewhere here, starting from here, then we expect here the graph is going to be representing secant. So the other possibility is we have y to be equal to a secant of kx plus a constant, say b. Now the question is, we need to find a, we need to identify b, and also identify what is k. Now to get started, let's start with a. A is very clear. The a, of course, in this graph there is no amplitude because it's representing secant or cosecant. But we know that there is a. A is going to be equal to, I have a problem again with my connection. What is the problem? Sorry, my connection is having a problem again. I connected with two tablets. Okay, I guess we are back now. So here we say a is going to be equal to plus or minus 1. Why do we say that? Because we know that the distance from here, the distance from here to here is going to be 1. And when we consider the distance here is going to be equal to also 1. So we know that the distance is equal to 1. So we can say the absolute value of a is equal to 1, which means a shall be equal to plus or minus 1 because of the absolute value. So we have a to be equal to plus or minus 1. Now the next thing is to find what is going to be our k. To find k, we can use the period. So the period is equal to the end of the graph minus the starting point of the graph, or the beginning of the graph. Now, what is the period? We know the period is 2 pi over k for the case of secant and cosecant. And this is going to be equal to the end here of one period, which is going to be equal to pi minus, that is going to be plus pi, and that is going to give us 2 pi. Now, let us observe. When we say 2 pi divided by k is equal to 2 pi, I can write it like this one clearly. We can say 2 pi over k is of course equal to 2 pi. So what does it mean? It means that our k shall be equal to 1. So we have good news. K is equal to What is the problem with my connection? I don't know. I have a problem with the connection again. Please allow me to restart the system, please, here. I'm really sorry about this one. The main connection is fine, but the other connection is having a problem, and that is the tablet that I use in writing. Sorry about this. Hopefully, when I restart it now, the problem will be solved. All right, sorry about that one. Okay, now, so here we say that the k is equal to 1. Now, let us get back. So the problem now is has to do with B only, and B is the horizontal shift, right? So what do? We know A. Now, let us observe something here. If our graph, for example, is starting from here, let's say the graph is starting from here. This, you will agree with me, is going to represent the graph of cosecant, right? What is the problem again? What is the problem? What is the problem? My sharing network is getting... okay, yes, I can see there is a problem within my sharing again. What is the problem? Why do we... Okay, let's continue now. Sorry about that one. So here, what we are saying, if the graph, for example, is starting from here, okay, you will agree with me that the graph of the here will be now representing a graph of, say, cosecant. Okay, now, so as I was saying, if, for example, I would like to consider the graph of this cosecant, here is going to be sine, right? Is going to be sine on the upper part. So the cosecant will be this graph. Now, if you see, this is our y-axis, so the graph is starting from 0. So that means there is no horizontal shifting in the graph. And if there is no horizontal shifting, what does it mean? It means the equation is going to be like this one. We have y equal to, now we are starting from the positive x-axis. We are starting from the positive here. So because we are starting from the positive, a shall be equal to 1. So we have 1. Then the cosecant of k. What is our k? K is equal to 1. So I'll put here x only. Okay, because we find the k to be equal to 1. Now, this is one of the equations that we have in case, for example, the graph is starting like this one here. This is our equation. Now, if you look at it, how about the graph is starting from here, for instance, and going like this one? There is nothing to worry about. When we are talking about the graph of cosecant or secant, sine or cosine, what is going to be the difference in the graph? I'll tell you the secret. Look at it. Now you see this one is starting from the negative part of y. Can you see that? So that means we start from the minus. So the graph will be y equal to minus cosecant of x. Now what do? You can always add and subtract pi from the original. So I can say here, for example, we are starting from minus pi, so this is going to be plus pi. Now I tell you what I'm saying here is this. If I start from the left side, I'm going to say minus pi from this part. If I start from the right side, I will say plus pi from this part, always true. So now let me show you the other part. For example, now what is going to be another possible equation? Another possible equation is going to be starting from here. Let's say I start from here. So you can see that again we are starting from the down part. But here we are saying that the horizontal shift is equal to pi. So that means the equation will be y equal to minus cosecant of x minus pi, because in this case it's shifted to the right. So now what I'm trying to say, please look at it. Let me explain it again. If I have y equal to cosecant of x here, now it is easy for me to find when the graph is going above or when the graph is going to the left side or the right side. What do? I can go to the other side. I'll put here minus pi, and here I'll say plus pi. If you do that one, you are going to get the other equations for cosecant or for sine. Now, let us talk about cosecant. Sorry, for the talk about the secant now. For the case of secant, what happened? What is going to happen? We have two options. The first option, I want you to look at the graph. Let's say, for example, the graph is starting from here like this. Okay, so we are starting here from pi over 2. So that means the horizontal shifting. What is horizontal shifting? Minus b divided by k is equal to pi over 2. Now we know k is equal to 1. So that means minus b is equal to pi over 2. And that means b is going to be equal to negative pi over 2. Now this is one possibility. How do I write it? I'm going to write it as y equal to a is 1. So I put here secant. But then k is 1. I put x. and then we put minus pi over 2. That is in this case here, we put minus pi over 2 if it is starting from the left side. But if it is the right side, it's going to be a different story. Now, let me show you something. Let me show you something. Please. Now, this is one way to do that. Now, let's say, for example, you do not want to do it this way. What is easier way? The easier way is from here. We can use co-function identity. I think you remember the co-function. We say that cosecant, or let's write here, we say that secant of pi over 2 minus x is always going to be equal to cosecant of x. You see the co-function property? Now I already find cosecant of x. So what do? This is going to be the same thing as this one. Now some of you will be looking at it, oh, the x is starting before the pi. Can I do something about that? Yes, of course we can. We can rewrite it. We can say this is going to be secant of minus x plus pi over 2. Then let us take minus as a common factor. So this is going to be secant of minus into x minus pi over 2. Now take the minus outside. Remember, this is an even function, so the minus will disappear. So we can write it as secant of x minus pi over 2, which is the same as this one. So you can see that we have many ways to write. In this case, if I have cosecant, I can write secant easily by using the co-function identity. Okay, now let's continue. So now let's use the idea that I explained to you before. Now that I have one equation for secant, can I add more equations? Yes, I can. How? I can say plus pi or minus pi. So we can find more equations. So if, for example, we add pi, we can say y is going to be equal to, please look up here. I want us to understand something here. Please look up. Here, we started the graph from here, right? To get this first one. Now, when we want to add pi, that means we are going to start the graph from the negative side. I'm starting the graph from here. So if I start the graph from here and stopping here, you will agree with me that we are going to start at minus 1 here, right? So this is going to be minus secant of x plus pi over 2. So now we added the pi to this one, giving us plus pi over 2. Now, how about if you want to go further? For instance, here, let's say I extend the graph, for example. If I extend the graph, what is going to happen, please? So we expect another graph to be down here. So that means the graph will start from this part, right? Now I am going to subtract. The graph is going to start from here. Now you see that it's going to start again from the negative part. So what is going to be another equation? It will be now y equal to minus. It's also going to be minus because it is minus 1. So we have secant of x minus. So we say minus pi over 2 is going to be minus 3 pi over 2. And that is going to be another equation. So you can see now all these equations represent the same graph. This one, this one, this one, this, and this one, all of them represent the equation of the same graph. So if you look at the multiple choice option now, you will agree with me that the right answer here will be equal to which one is this one here? I think the right answer here is going to be E, option number E, which we can see that it is this graph here. So if we have one graph Can we always find another one? Yes, we can, using the co-function identity or maybe using the starting point of the graph. Please, are there questions here before I continue? Okay, so you can also ask questions when we move to the end of the section. Okay, now here. Now.
Can you repeat how we use co-function identity to have that?
Okay, we have a cosecant of x. This is one of the options when the graph is starting from the first quadrant, like this one. Now, if I want to find the graph of cosecant, secant, what do? I can use the co-function identity. Now, what is the co-function identity? We know that secant of pi over 2 minus x is always equal to cosecant of x. Now, we can play game with this one because we want it to be the variable before the angle. So what do? We are going to rewrite it this way. So this is what we are looking for. This is our answer. But rewriting it, we can say secant into minus x plus pi over 2. Now you take minus as a common factor. So we can write it as secant of minus then x minus pi over 2. And then sine is an even function. So this minus, we can throw it away. So we can say this is going to be equal to secant of x minus pi over 2. I hope this is clear now.
Yes, thank you.
Okay, now let's go to the second question. What does the question say? The question says if the domain of pi plus 5 cosine inverse of x over 2 plus b is given in this interval, then 2b plus 1 is going to be equal to what? So our target is to find this value of b. Now, how do we do that? Now, we need to understand first, what do we get? What is the domain of sine and what is the domain of cosine inverse? So let me write it out here in case we want to further study. For instance, now, if we have sine inverse, the domain of sine inverse is always from minus 1 to 1. And then the range for the sine inverse, we know is minus pi over 2 to pi over 2. Now, for the case of cosine inverse has the domain of minus 1 to 1, and the range of cosine inverse is from 0 to pi. So this is what we know from section 6.5. Now the question is asking to find the domain of cosine inverse. So what we do, to find the domain, we write out this one, the domain now. We take the argument. This is what is in front of cosine inverse, and that is our argument. So the argument should be between minus 1 and 1. So here we have minus 1 less than or equal to, because it is a closed interval, then we have x over 2 plus b, and this is going to be less than or equal to 1. Now for simplicity, I always prefer to clear the fraction. So let us multiply by 2 to clear the fraction. So we are going to get here minus 2 less than or equal to, now we're going to have x here plus 2b, because we multiply by 2 less than or equal to, here we have 2. Now what do we do next? Central interval, we are going to subtract 2b from each of the side. So we can say minus 2b minus 2 less than or equal to x, and then less than or equal to minus 2b plus 2. Then we have a good news. Comparing with this interval, The question tells us that the interval is 3 less than or equal to x, which is actually less than or equal to 7. So what does this one mean? Therefore, we can say minus 2b minus 2 is equal to 3. And also, minus 2b plus 2 is equal to 7. Now, we can solve one of them is enough. We don't need to solve both of them because both of them will give us the value of b to be the same value. Now, let me show you both of them, but we don't need both. We need only one. So here, if I want to solve for b here, we say minus 2b is going to be equal to 5, and b will be equal to minus 5 over 2. Now, similarly, if you solve the other one, we say minus 2b will be equal to 5. Please, Fatima, can you close your mic? Okay, so this is going to be equal to 5, and that means b will be equal to minus 5 over 2. So you can see here that we have the value of b to be the same, so we don't need to solve both of them. One is enough. Now let us go back to the question. The question wants us to find 2b plus 1. So we can say, therefore, 2b plus 1 will be equal to 2 into minus 5 over 2 plus 1. And then you can say 2, we go with 2, and then we say minus 5 plus 4 plus 1 is going to give us minus 4, which is our answer in this case. So here, the option is the first one, A. Questions, please. Okay, then let's proceed if there is no question. Now let us look at this beautiful question. It says the expression is identical to what? Now, we can solve this question in more than one way. As a matter of fact, what comes to the mind when we see this type of question is to change everything to sine and cosine, which is perfect. But I tell you one thing, whenever we change to sine and cosine, we may have to do more extra work to get the answer. So when we have a question like this one, we think if we have a property that we can use to simplify easily, then deal with the property. Now, for instance here, we have a property for tangent squared, which is related to secant. Now, since there is a property of tangent related to secant, it will be much better to use this property. Which property am I talking about? We say we have 1 plus tangent squared of x is equal to secant squared of x. And that means tangent squared of x is equal to secant squared of x minus 1. So let us use this property, and it will be more interesting and much easier. So if that is the case, therefore, I can rewrite. We can say the tangent squared, we can write it as secant squared of x minus 1 divided by 1 plus the secant of x, which we can write it as secant of x plus 1. Why did I write it like that one? Because addition is commutative. A plus B is always equal to B plus A. Right? Now, what do we do next? If you look at numerator, you will agree with me that this is difference of 2 squared. That means we have A squared minus B squared, which we can write as A minus B multiplied by A plus B. So let us use this beautiful property. So for numerator, we can write it as secant of x minus 1 multiplied by secant of x plus 1. And in the denominator, nothing is changing in the denominator. We have it as secant of x plus 1. Now, you will agree with me that this, we cancel out with this one. So what are we left with? We have secant of x plus 1. Now, this is our simplified answer. Now, if you look at it, it's not part of our multiple choice. So what do? We can now change this one to cosine. 1 over cosine of x plus 1. Now, when you take the LCD, what do we get? We are going to get 1 plus cosine of x divided by, of course, cosine of x. Now, if we, this is minus because we cancel the positive. So we are left with minus. So here, this is going to be minus. Okay, so you can see that this one is, of course, in the multiple choice, which, of course, is A. Now, observe that also, this is possibility in case it is in the multiple choice. And then we can also say this is possibility and this is a possibility. Now, as I said earlier, can I solve this question in another way? Yes, of course, you can. What is the other way? We are going to rewrite here. We can say tangent. We write it as sine squared of x over cosine squared of x. Then divide everything by 1 plus 1 over cosine of x. If you do this one, you are going to get the same answer. How? I will explain. You see, this is going to be equal to sine squared of x over cosine of x divided by, take the LCD for this denominator. We are going to get cosine of x plus 1 over cosine of x. Now, this cosine squared, the power here, we cancel with this one here. And then we are left with, if you look at it very well, you are left with sine squared of x divided by cosine of x. Now, let me take the reciprocal. We can say 1 over cosine of x plus 1. Now, what do? I am going to change this one to cosine. If I change it to cosine, I'm going to get this one to be, sine squared is going to be 1 minus cosine squared of x divided by cosine of x into cosine of x plus 1. Now, you see that this one is again difference of 2 squared. That means 1 minus cosine, 1 plus cosine. So if you cancel that one with 1 plus cosine, you are left with 1 minus cosine over cosine, which is going to give you the same answer. But as I said, the calculation is going to be more as compared to when we use the property. But can you use it? Of course you can. The choice is yours. Any question, please? Okay, now, let's go to example number 4. Here, it says if the function y is given to us, is written in this form, then what is going to be k, b, and c? Now here, we have to be very careful. This is what we call reduction identity. I don't know if you remember this one from 7.2. We have a sine of, let's say, x plus b cosine of x. You see, this we can always write it as k multiplied by sine of x. This angle must lazim be the same before we can use this reduction identity. So, plus an angle called alpha. So what is this k? This k is equal to square root of a squared plus b squared. And what is this alpha? How do we get this alpha? It says tangent of alpha is always equal to B divided by A. This we call reduction identity. Now let us look at the question again. If you look at the question, we have a good news. What is the good news? Allow me to rewrite this y. So we are going to say y is going to be equal to, now this one is going to represent A, and this shall represent our B. So I'm going to call it a K now. So we have sine of, we have the angle to be the same, a half x, a half x. We can use the reduction identity because the angles are the same. So we have 1 over 2x plus alpha. Now we have extra term. Because of this extra term, we can put it as it is. We don't have anything to do with the extra term. That has to do with the vertical translation, shifting up or down, divide by 2. So now we have a good news. What is the good news? Observe that we are looking for K. We don't know K, but we know B. This is our small b, and this is our C. So you can see clearly that we know that B is equal to 1 over 2. And also, you can see that we have our C to be equal to 11 over 2. So you can see here, I don't need to find B, I don't need to find C. It's already given. Okay, now let us go and find the value of K. What is going to be our K? According to the reduction identity, the K is going to be equal to the square root of A squared plus B squared. Now, what is this one here? We write it as root of 1 over 2 squared. That is going to be 1 over 4 plus, now, square root of minus 3 minus root of 3 over 2. When you square that one, we get 3 over 4. And this is going to give us root of 4 divided by 4, which of course is equal to 1. And root of 1 is going to be equal to 1. So you can see that we have K to be equal to 1. Therefore, what is the question asking for? The question wants us to find K plus B plus C. And this is going to be equal to 1 plus B. That is going to be 1 over 2 plus C. And that is 11 over 2. Now we have good news. We can add the last two together. What I mean, we can add this one together. This is going to give us 11 plus 1. That is going to be 12 over 2, which is equal to 6. So we can write it as 1 plus 6, and the answer will be equal to 7. And that is what we are looking for. So here, we use the reduction identity. Now observe something here. What do I want you to observe? The question did not ask for the alpha. And since the question did not ask for the alpha, I do not need to find the alpha. And as a matter of fact, I do not need to find which quadrant we are dealing with. Because I'm not asking, the question is not asking for the alpha. But if the question asks for the alpha, then we need to know which quadrant we are, and then we can find the tangent of alpha, which is equal to B divided by A. Questions, please. Okay, now let us continue. Number 7. Number 7 is a very beautiful old exam question. And this question, I can say it's more or less like A. Why? Because it combines two ideas in one. Why? And why did I say that? You see, we have cosine of 2 alpha. This is double angle. Now, it gives me alpha to be in quadrant number 1. So here, we have alpha to be in quadrant number 1. Because alpha is between 0 and pi over 2. So you agree this is quadrant number 1. But we are dealing with double angle. So this is times 2 and this is single angle. So we have to be very careful how we deal with it. Now the second one. The second one, again, we are given the double angle of beta. But observe that here, beta is in quadrant number 2. So here we have double of the angle, but here we have single angle. So we have to be very careful again in transforming between double angle and single angle. Then the question wants you to find the tangent of alpha minus the beta. How can I find the tangent of alpha minus beta? So that means I have to convert all the double angle to single angle. Now please, let us look at it. Here, I want to look at the double angle of cosine. Is there a way we can convert the double angle of cosine to single angle? Yes, of course. We have 3 properties. Now, the choice is yours. You can use any one you like. Now, you see, I can use the one that contains only one single trigonometry. We know that the cosine of 2 alpha is equal to 2 cosine squared of alpha minus 1. Or we can say this is equal to 1 minus 2 sine squared of alpha. Now we can use any of them. Remember, there is also cosine squared of alpha minus sine squared of alpha. But I'm trying to avoid this one. You know why? Because it contains 2 trigonometry. Dealing with 2 trigonometry is not a good idea. It is better to use one single trigonometry. So now, if I use the first property, what do we get? Let us use this one. So you will agree with me that in the first case, if we use the first property, we are going to say here 2 cosine squared of alpha minus 1 is going to be equal to 7 over 25. Now, take this one to this side. We are going to say here 2 cosine squared of alpha is equal to 7 over 25 plus 1. So that is going to be equal to, when we add 1 to that one, that is going to be 25 plus 7, and that will give us 32 divided by 25. So we write it as 32 over 25. Now divide both sides by 2. If we divide both sides by 2, what do we get? We get cosine squared of alpha to be equal to 16 over 25. Now we have here cosine of alpha is equal to plus or minus square root of 16 is going to be equal to 4. Divide by square root of 25, which is going to be equal to 5. Now I'm in trouble. Plus or minus? Should it be plus or minus? No. We are dealing with which quadrant? Alpha is in quadrant number 1. So that means cosine is positive. So here I am going to pick only positive because we are dealing with quadrant number 1. Now, if I have cosine in quadrant number 1 to be positive, I can find tangent easily because at the end of the day, I'm interested in getting the tangent. So if I like, I can bring out the picture. Okay, what do I mean? You can bring out the picture in quadrant number 1 like this. So if this is quadrant number 1, we have the y-axis and then we have the x-axis. Then what do? Let us draw in quadrant number 1. The drawing is not important, but when you draw it, it makes life easy for you. So here, this one goes. So let us bring it down. So what do we have? We say the adjacent is equal to 4, the hypotenuse is equal to 5, and the opposite, if we use Pythagoras, is going to be equal to 3. So you will agree with me that the tangent now of alpha is going to be equal to opposite, that is going to be 3 over 4. That is tangent of alpha. Now, we are done with the first part. Let us go to the second part now. For the second part, what is the problem here? The problem is that we have only one property for the double angle for sine. What is that property? We know that sine of 2 beta is equal to 2 sine beta cosine of beta. Now, if I rewrite this one, if we say 2 sine beta multiplied by cosine of beta equal to minus 1, then we can say sine of beta cosine of beta is equal to minus 1 over 2. Now, I'm in trouble. Why are we in trouble? We said sine multiplied by cosine is equal to minus a half. Gentlemen, unless I have more information, I cannot be able to do this one easily. That means using the single angle, or using the property of double angle here, will not give me the answer easily. So what is going to be the idea now here? The idea to complete this one, we can go to section 7.4 using the equation. Okay, so what do? Here we are going to say, because we know that sine is going to be equal to minus 1 only when we are here 3 pi over 2. So sine is going to be equal to minus 1 when the angle is 3 pi over 2. So what am I saying? So this one here, it means 2 beta is equal to 3 pi over 2. Now, because if I go around the circle, there is a possibility that the coterminal will also be an answer. So I'm going to say plus 2n pi. I am not sure if I'm going to need this 2n pi or not, but I'm giving the general solution here. Let's continue. Then what happened? Let us divide both sides by 2. So that means beta is going to be equal to, if I divide by 2, we'll say 3 pi over 4. Now, this one is going to be plus n pi if I divide by 2. Now, do I need this n pi any longer? I don't think I will need it. You know why? Because it tells me that beta is in quadrant number 2. Beta is in quadrant number 2. So in quadrant number 2, I am not going to need this one again. I don't need this one. But the general solution will contain that. So I don't need this one because I am in quadrant number 2. So we can say, therefore, our beta is of course equal to 3 pi over 4, which implies is that we are talking about quadrant number 2. Now we have the beta. Now that we have the beta, the question is asking us to do something. What is the question asking us to do? It wants us to find the tangent. Now, before I find the tangent, here, let me find the tangent of beta. So therefore, the tangent of beta is going to be equal to the tangent of 3 pi over 4. That is in quadrant number 2. Tangent is negative. That is going to be equal to minus. Tangent of pi over 4 is equal to 1. So we have the answer to be minus 1. Now let us go to the question itself again. What does the question say? The question is looking for, so we are looking for, I don't have much space, but let me write here like this. Tangent of alpha minus beta. This is going to be equal to, if I use the property, it will be tangent of alpha minus tangent of beta divide by 1 plus tangent alpha and tangent of beta. And this will be equal to, what is tangent of alpha? Tangent of alpha is 3 over 4 minus tangent of beta is equal to minus 1. Minus 1, it will be plus 1. Divide by, we have 1 plus tangent of alpha, that is going to be 3 over 4 multiplied by minus 1 is going to give us minus 3 over 4. If I simplify this one, this is going to give us 7 over 4 divided by 4 minus 3, 1 over 4. And what will be the answer? the answer is going to be equal to 7 divided by 1, which is going to be equal to 7. So the answer is equal to 7. Do you understand it? Any question, please? Maybe something is not clear to you. So you can see here we have used the property in the first part. We have used the property of the double angle. In the second part, the property of the double angle has failed us. So what did we do? We used the idea from 7.4 as equation to answer the question. Questions, please. Okay, now. Further.
For tan alpha minus beta, why don't we, Doctor, 3 over 4 minus 1?
No, that is not the property of tangent. Not only tangent, yani, even the sine, cosine, secant, cosecant, all of them is not like this one. What you are saying, for example, here is this one. Tangent of alpha, let's say minus beta. Can we say this is equal to tangent of alpha minus tangent of beta? No, it is not true. The property is going to be divided by 1 plus tangent of alpha and tangent of h beta, right?
Yes.
Yes. So we cannot afford to make mistake in the property. Or any other question?
Mr.
Fadal.
Is it possible to solve cosine to beta by using cosine to cosine square x minus sine square x?
Cosine to beta to be what?
Cosine square x minus sine square x.
Yes, we can do that one. That's what we said before. We cleaned it. We said this property we can use, but because it contains 2 trigonometry, we are not going to find the answer easily. But using the 1 trigonometry is faster. But yes, we can use this one also. Okay, now let us continue. In example number 6, what does the question say? It says the number of the solution of the equation. So how many solutions do we have of this equation over this interval from 0 to 2 pi? Now here, if you look at it, we have tangent squared, we have tangent of x, then we have minus root of 3, and we have root of 3 and tangent of x. What do we do? Let's try to bring them together on one side. So if we do that one, we are going to get tangent squared of x plus the tangent of x. Now bring this one to this side because it contains tangent. I would say minus root of 3 multiplied by the tangent of x. Now this one we have negative root of 3 minus root of 3, and we can say this is equal to 0. Now you see, if you can remember, in 0, 0, 1, when we have more than 3 terms, we always think of grouping. Similarly here, we have more than 3 terms, so we should be thinking of grouping. Now if we try to group, you will agree with me that we can say tangent here is going to be a common factor, and here we can say root of 3 or negative root of 3 will be a common factor. So let us deal with it. So here we can say tangent of x is the common factor, then bracket open, we are left with tangent of x plus 1. And in the second part, we can say minus root of 3 is a common factor, then here we are left with tangent of x plus 1, because we have taken root of 3 as a common factor, and this is equal to 0. Now we have good news. We have a common factor between the two groups. So let us take the common factor out. So therefore, what do we get? We get bracket open tangent of x plus 1 into tangent of x minus root of 3, and this is equal to 0. Now, what do we have? If both of them are equal to 0, we can say tangent of x will be equal to -1, or we can say the tangent of x will be equal to square root of 3. Now, this is interesting. Tangent is negative. In this question, I have to tell you something. You see, we know that when we talk about the tangent, we always have to be very careful when we have tangent and cotangent. Tangent is equal to sine x over cosine of x. So in this question, we need to have a note. Note here that cosine of x cannot, of course, equal to 0. So if we have a value in which cosine of x is equal to 0, it will be undefined, and such a solution will have to be rejected. And you remember, we know when cosine is going to be equal to 0, right? Cosine is going to be 0 at pi, at 0 and pi. We can say 2 pi, and we can say multiple of n pi, right? So do not forget that one. So let us continue here. Here, tangent is negative. That means quadrant number what? Quadrant number 2 or quadrant number 4. And then here we can say also that the tangent is positive. That is going to be quadrant number 1 or quadrant number 3. So that means we are going to find our answer in each of the quadrants. So which quadrant let's start with quadrant number 2 now. In quadrant number 2, what famous angle is going to give us the tangent to be equal to -1? Tangent is going to be equal to -1 at pi over 4, right? But now in quadrant number 2, so we are going to say we have pi minus pi over 4. Let me write it as x. X is going to be equal to pi minus pi over 4, and that is going to be equal to 3 pi over 4. Now let's go to quadrant number 4. In quadrant number 4, what is going to be our answer? Again, we say x is going to be equal to, in quadrant number 4, we say 2 pi minus pi over 4, and this is going to be equal to 7 pi over 4. Now, this is in 2 quadrants. Now, what about in quadrant number 1? For this other case now, in quadrant number 1, which famous angle is going to give us tangent to be equal to root of 3? Root of 3, that is going to be 60 degrees, right? So let us say, now here we are going to say our x is going to be equal to, in quadrant number 1, x is going to be pi over 3. That is 60 degrees. And when we go to quadrant number 3, here we say x is going to be equal to pi plus pi over 3, and this is going to be equal to 4 pi over 3. Now, remember that we are looking for the answer in between 0 and 2 pi. So we don't need to find the general solution first. So how many solutions do we have that are inside the interval? You will agree with me that this is inside the interval, this is inside the interval, this is also inside the interval, this is inside the interval. So in general, the number of solutions is going to be equal to 4. All right. Is there any question, gentlemen? Apologies, sorry. Also, ladies, yes.
When we have to put 2k pi.
Okay, I will show you. When we put 2k pi, if we have like a multiple angle, for example, if I want the question like this one, tangent of 2x, for example, I have a multiple angle, or maybe if I, for example, have tangent of x over 4, for instance, then it is better to always put the 2n, the coterminal angle, so that we are careful. But when we have a single angle, then we don't need to worry about it. Is that clear?
Doctor,
Now,
when we have to check our answer?
if you have tangent or cotangent, or secant or cosecant, any of them that is having a rational, for example, we say tangent is equal to sine over cosine. So cosine cannot be equal to 0. If cosine equal to 0, then that solution has to be rejected. If you have cotangent, this is equal to cosine over sine. Now sine cannot equal to 0. So here, what are the zeros of cosine? It is n pi. What are the zeros of sine? Is going to be n pi plus pi over 2. So we need to remember this. Whenever you have a denominator, then you have to be very careful. It is not a checking, but always remember that if we get, for example now, if we get one of the answer here that x is equal to pi, then we are going to reject that answer. If I get one of the answer x is equal to 2 pi, I have to reject it, because that is going to be zeros of denominator for tangent. Is that clear?
Yes, thank you.
All right. Now let us continue. Number 7, it says the sum of all the solution of the equation. Now, if you look at this equation, I can see something inside the bracket here, and here we have a bracket. So what do? Let us bring them together on one side so that it is easier for us. So here we can say we have 2 sine of theta, then we have sine of theta minus 1. Now bring this one to this side. We have minus 3, then bracket open, sine of theta plus 1. And we can say this is equal to 0. Now we are in trouble. You know why? You see, this is minus. But look at this one, it is plus. Can I say by grouping sine of theta minus 1 out, and then 2 sine of theta minus 3? I cannot, because they are not the same. So what do we do in this type of question? We should open the bracket. Now, if we open the bracket here, what do we get? We say 2 sine squared of theta minus 2 sine of theta. Now open the bracket here also, minus 3 sine of theta and minus 3. And this shall be equal to 0. Now, you see, this is very beautiful because these are the same. So we can combine them together, right? We have sine of theta, and here we also have sine of theta. Now we can combine it together and write it as 2 sine squared of theta minus 2 minus 3, that will be minus 5 sine of theta minus 3 equal to 0. Now, if we let u, if for example, we let u equal to sine of theta, then we can write this one as 2u squared minus 5u minus 3, of course, equal to 0. Then let us factor. We can say 2u and u. We can put here 1, and here should be 3. And this shall be negative, and this will be positive, right? So the factor will be 2u plus 1 into u minus 3 equal to 0. Now, what is our u? U is equal to minus 1 over 3, sorry, 1 over 2, or u is equal to 3. Now, what is our u? from the question, we can say, therefore, sine of theta will be equal to minus a half, or sine of theta is equal to 3. Now, is it possible for sine to be equal to 3? Is it possible for sine to be equal to 3? Of course, it is impossible. Sine oscillates between -1 and 1. The maximum value is 1 and the minimum value is 1. So the range of sine is -1 to 1. So this is impossible. So this is impossible. So we shall reject this one. Now that this one is rejected, what do we have? We have sine to be equal to negative. Negative number means we are going to be in 2 quadrants. This means quadrant number 3 or quadrant number 4. This means quadrant number 3 or quadrant number 4. So let us find the answers in these 2 quadrants. In quadrant number 3, which famous angle is going to give us sine to be equal to a half? That should be 30 degrees, right? Which is going to be pi over 6. So because the interval is in degree, so we are going to write our answer in degree. So that means our theta is going to be equal to, in quadrant number 3, we say 180 degree plus 30 degree, which is going to be equal to 210 degrees. How about quadrant number 4? In quadrant number 4, we say theta will be equal to 360 degree minus 30 degree, and that is going to be equal to 310 degree. What is the question asking for? The question says the sum. So what is going to be the sum? If I combine this one together, we say this implies is the sum is going to be equal to 210 plus, no, sorry, this one is not 310. This is going to be 330. So 210 plus 330, and that is going to give us the sum to be equal to 540 degrees, and that is the sum. So here we must not forget, because this one we said is impossible, it is of course rejected. So we cancel this part. We did not accept this one. Any question, please? Okay. Let's go to number 8. Here it says, if the vector u has magnitude 8 and directional angle to be equal to pi. This is a question from section 9.1. And the vector v is given. Then the directional angle of alpha of the vector u plus v is equal to what? So let us start with vector u. Now the vector u is going to be equal to, usually we can write a vector, any vector, let's say u, to be equal to the magnitude of vector u multiplied by the cosine of the angle between the two of them, theta, and then the magnitude of vector u multiplied by the sine of the angle theta. So here we say this is going to be equal to the magnitude of u. The magnitude of u is 8. So this is going to be 8 multiplied by cosine of pi, common 8 multiplied by the sine of the angle between the two of the angle, which is going to be equal to 8 again. The directional angle is 8. Sorry, it's pi. So simplify this one here. We get 8 multiplied by -1, common 8 multiplied sine of pi is 0. And this is going to be equal to -8, common 0. So now we have the vector u. What next? We are going to find u plus v. So therefore, we say u plus v is going to be equal to our vector u is minus 8, 0. Now what is vector v? Here we have 4, and then the vertical component is also 4 root of 3. Add them together. This will be equal to minus 8 plus 4, and that is minus 4, 0, plus this one is going to be 4 root of 3. Now, we are given the vector u plus v. Now, what do we do next? We want to find the direction of this vector. How can I find the direction of the vector? I need to know which quadrant we are dealing with. Now, how do we know the quadrant? Here, we're going to call this one A, and let's call this one B. So here, this implies is, okay, I can write this one, the A is negative and the B is positive. A is negative and B is positive, and that means we are in quadrant number negative and positive. That is quadrant number 2, right? We are in quadrant number 2. So now, let us find the directional angle. To find the direction, what do? We use tangent. So for the directional angle, we say tangent of here, we can call it, because they call it alpha, we can call it alpha, is equal to B divided by A. So what is our B? The B is equal to 4 root of 3 divided by A, which is minus 4. And this is equal to minus root of 3. Now, which famous angle is giving us tangent to be equal to root of 3? That is going to be 60 degrees, which is pi over 3. But we are talking of quadrant number 2. So therefore we say in quadrant number 2, what is going to be our alpha? Alpha is going to be equal to pi minus pi over 3. And this is equal to 2 pi over 3, because we are in quadrant number 2. Now, you see, we have a good news. Sometimes in multiple choice, you can eliminate the answer, because we know that we are dealing with quadrant number 2. You will agree with me that this is a possibility, and this is also a possibility. But this is out automatically. This is out and this is out, because they are in quadrant number 3 and quadrant number 4. So because we know that our answer is going to be in quadrant number 2, we can use this one as elimination skill if there is no time. Any question, please? Okay, now let us proceed. Number 9, it says if alpha is the angle between the vector u and v. When we say the angle between the vector, it is always the smallest positive angle between the two vectors. So here we can write it as always, cosine of alpha is equal to u dot v divided by the magnitude of u multiplied by the magnitude of v. So to get started, because we are looking for the tangent of alpha, to get started, we need what is the dot product. That is going to be u dot v. What does it give us? We have vector u, that is going to be 1, common here, we have 3, multiplied by the vector v, we have minus 1 and also common 3. If we multiply them together, 1 multiplied by minus 1, we get minus 1 plus 3 multiplied by 3, and that is going to give us 9, which is going to be equal to 8. So the dot product here is equal to 8. Now, what is the magnitude of vector u? The magnitude of u is going to be equal to root of a squared, and that is going to be 1 squared, plus 3 squared, which is going to be root of 1 plus 9, which is going to give us root of 10. How about the magnitude of vector v? This again is going to be equal to root of minus 1 all squared plus 3, of course, squared. And this is going to be the same thing, root of 1 plus 9, which is going to give us root of 10. Therefore, we can say now the cosine of alpha is equal to u dot v. What is u dot v? That is given by 8 divided by the magnitude of u, root of 10, multiplied by magnitude of v, which is root of 10. And this is going to be equal to 8 divided by root of 10 multiplied by root of 10, and that is going to be equal to 10. Simplify that one, we say 4 over 5. Now observe that cosine of alpha is equal to 4 over 5, and we are talking about quadrant number 1. So then what is going to be the tangent? So this implies is the tangent. Here, do not forget that when we say cosine is equal to x over r. Now by Pythagoras, you will agree with me that y is going to be equal to 3, right? So therefore, we can say the tangent of alpha will be equal to the y over x, which is equal to 3 over 4. And that is our answer. Questions, please. So if the question asks us to find the angle, then what we are supposed to do is to find the alpha by taking the cosine inverse of inverse of both sides. So if you take the cosine inverse of both sides, that will give you an answer in quadrant number 1 in this case, because u dot v is positive. So that means we're going to get answer to be in quadrant number 1. Okay, let us continue. Now, number 10, here is a question from 10.1. It says, if the order pair is the solution of the system, then what is going to be A plus B? So the solution, which is x and y, is denoted by A and B in this case. So to deal with this type of question, because of the fraction, of course you can use elimination method, but that is not a good idea here because of the difference in the number and the difference in the coefficient of x and y. So what is the best way? We clear the fraction. So here we have equation number 1. And here we have equation number 2. So to clear the fraction, we multiply equation number 1 by the LCD. So equation number 1 we multiply by the LCD. And what is the LCD for equation number 1? The LCD should be 10, right? I'm looking at the denominator. So the LCD here is 10. So if you multiply by 10, then 10 here, it will cancel here, and we are going to be left with 2. 10 here, we cancel with this 10. So these 2 we multiply here, we get 2x. The 2 we multiply here is going to be plus 12. But because 10 here cancel with 10, here we are left with 2y minus x, and this is going to be multiplied by 10, and this is equal to 10. Equation number 1 completed. Now let's go to equation number 2. The LCD here is going to be 20. So let us multiply by 20. If I multiply this one by 20, this we cancel this one, we are left with 5. And then by 20 here, this we cancel this one, you are left with 4. So 5 we multiply here, we get 5x. 5 multiply here, we get plus 10. But then 4 multiply this one, we get 12y. And then 4 multiply with this one, plus 8 equal to, multiply this guy by 20, we get minus 60. Now, you can see that we are done with the fraction and life becomes much easier now. So what do we do next? Let us rewrite both of them. So if I rewrite this one here, we can have 2x. No, it's not 2x here because we have 2x here and we have minus x here. So we are going to be left with x here. And then we have plus 2y. And this will be equal to 10. Now, how about this one here? We have 5x. So let's put here 5x. And then y, we have plus 12y. And this will be equal to, we have 10 plus 8. That is going to be 18. 18, take it to the other side. That is going to be minus 60 minus 18. That is going to be minus 78. Right? I hope I'm correct. Now, let us call this one here equation number 3. And let's call this one equation number 4 for simplicity. Now, we can use the elimination method easily. We can eliminate x or eliminate y. If I want to eliminate x, for instance, I would say equation number 3, let's multiply it by minus 5. So we are going to get here minus 5x minus 10y, and this is going to be equal to I think we did here. We have something here that I'm missing. This is minus 2, please. Okay, now we continue. So here I multiply by minus 5. So we have minus 5 minus 10, and then multiply this one by minus 5, and this is going to be back to 10. Good news. Now, equation number 4, we are going to multiply only by 1. That means no change in number 4. So here we have 5x plus 12y and equal to minus 78. Now, let us subtract. Here, the 5 is eliminated. And what am I left with? Here we are going to be left with 2y to be equal to, when I add this one together, I'm going to get minus 68. And that means y will be equal to minus 34. So we get y to be equal to minus 34. Then how do I get x? We can substitute for y in equation number 1 or equation number 2 or 3 or 4. If you look at it, it will be easier in number 3. But you can use any equation you like. The choice is yours. So therefore, we have x plus 2y. That is going to be 2 into y is minus 34. And this is equal to negative 2. So we are going to get minus 68. Minus 68, take it to the other side. We have x to be equal to 66. Now, what is the question saying? It says A and B. So here, this is our B, and this is actually our A. So we can say, therefore, A plus B will be equal to 66 minus 34, and that is going to be going to give us a positive 32 as our answer. So the answer here, it is B and not A, not minus 32, but positive 32. Questions, please. Okay, now, let's go to 11. 11 is nonlinear system of equation, that is 10.4. It says if the system has the solution AB in the first quadrant, so the answer we are looking for should be in the first quadrant. Now we have good news here. We have x minus 1, x minus 1. We have y plus 1, y plus 1. So what we can do is to use the elimination method. We can eliminate x or eliminate y. The choice is ours. Now eliminating y means multiplying by a smaller number. So let us call this one equation number 1, and this is going to be equation number 2. So equation number 1, we are going to multiply by 1. We don't want to change equation number 1. So here we have 3 into x minus 1 all squared minus 2 into y plus 1 all squared equal to 19. Now equation number 2, we want to eliminate y. So we are going to multiply by negative 2. So here we are going to get minus 2 into x minus 1 all squared. Here we're going to get plus now 2 into y plus 1 all squared equal to minus 10. Now let us eliminate y. So this is out. Now what are we left with? We are going to be left here 3 minus 2. So we have x minus 1 all squared, and this is going to be equal to 9. So therefore, we have x minus 1 squared is equal to 9, and that means what? It means x minus 1 is equal to, when you take the root of both sides, is going to be plus or minus 3, and that means x is going to be equal to 1 plus or minus 3. And when we say plus or minus 3, it means we have two values for x, right? So here, what does it mean? We have, this implies is we are going to have two possible values for x. We have x to be equal to, we take 1 minus 3, and that is going to be equal to minus 2, and x is equal to 1 plus 3 and 4. But because the question tells us that we are in the first quadrant, in first quadrant, x should be positive. In quadrant number 1, what does it mean? It means x to be greater than 0, and also y to be greater than 0. So we are going to consider only this one here. I don't care about negative, because negative will not be in quadrant number 1. So therefore, I am going to substitute now. Substitute x equal to 4 in any of the equation we like. For example, you can say put in equation number 1 or put in equation number 2. The choice is ours. Let me use equation number 2. So therefore, what do we have? We have x to be equal to 4. So here we have 4 minus 1, and that is going to give us 3 all squared minus, we have y plus 1 all squared to be equal to 5. Now let us simplify. What does it mean? It means y plus 1 all squared, take it to the right side and take 5 to the other side. That is going to be 9 minus 5, and that is going to be equal to 4. So here we see y plus 1 is going to be equal to, again, plus or minus 2. So here we say y is going to be equal to minus 1 plus or minus 2. Again, we can say this implies is that y shall be equal to minus 3 or y will be equal to 1. Now, I cannot take y to be equal to minus 3 because negative means not quarter number 1. So this is the combination I'm going to use. So which solution am I talking about? So therefore, the solution we need in quarter number 1 we have x common y, which is called a and b, is going to be equal to, our x is equal to 4 and y equal to 1. So the question says, what is a plus b? So the sum, therefore, the sum is going to be equal to 5 as our answer. So you can see here, the answer is actually C. The sum is equal to 5. Questions, please. Okay, number 12. Here it says, if the augmented matrix of the system of linear equation is given by this. So this is the augmented matrix. Is given by this. Then the system is inconsistent when x is equal to what? Now, of course, this one has a relation. We say inconsistent means no solution. Now let me spell out what we need. For example, if we have inconsistent, it means no solution. Inconsistent system means no solution. So if we have a matrix form and you want to put no solution, in the bottom row, you are going to put 0, 0. It is 3 by 3 matrix, 0. And then that means the last one here cannot equal to 0. So this we need to understand. Now, some people may be, okay, let me answer this question and then we talk about the rest, the other possibilities of a different answer. So here, what do? It says this is 0, this is 0, this lazim should be equal to 0. So we say, therefore, x squared minus 4 should be equal to 0, and this guy cannot equal to 0. X minus 2 cannot equal to 0. So let us solve it. So here we have x squared is equal to 4. So we can say x is equal to plus or minus 2. Now this and here, we can write it in set form as intersection. And here we have x cannot equal to 2. So x cannot equal to 2. X is equal to plus or minus 2. What does it mean? When you take the intersection, it means x will be equal to negative 2. X is going to be equal to negative 2, which is our answer in this case. Now, what if the question asks for dependent system? Now, for dependent, that means infinitely many solutions. For dependent system, the bottom row should be 0, 0, 0, and the constant also lazim 0. So infinitely many solutions. What if we have independent system? If the question tells us independent system or a unique solution, or you say one solution, here we are going to put 0, 0. This is not equal to 0. Now, the constant, you don't care about the constant. It can be any number, you don't care about it. So this is what we have. So dependent means infinitely many solutions. Independent means exactly one solution or a unique solution. Now, this marks the end of the app session today. Now, if you have a question, you can raise up your hand to ask the question now before I post the solution in the Microsoft team.